YouTube there watching, picket fence ball impalements.
Sometimes I feel bad about it.
What? You feel bad about watching picket fence ball impalements?
No.
Or you feel bad about watching my math and you click like?
Yeah, I feel bad that you have no views.
I couldn't care less. As a matter of fact, Noah, I'm actually happy that I have no views. Because then,
Everybody gets it.
yeah, that's what it means. We'll say that's what it is, Joel.
Yeah.
That means everybody gets it. Okay, so
It means nobody cares.
the actual reason is that none of you care enough to get it. And then when you get a bad test mark and you try to blame me, I can say, no, because here's all the notes I taught you. Here's how many times the video was rewatched. Right? The only thing that would make it better is if I could somehow find a way to make you to track who was actually looking at it on YouTube. Then I could say when John Smith's mom comes in and says, well, he was always good in math before you, and then I can say, well, he's not really trying here, is he? Because he doesn't pay attention in class, he doesn't do any notes, and he doesn't watch the videos. How do you know he doesn't watch the videos? That's what I'd really like. If I could put the videos on Moodle, I would in a second. Then I could see who was actually logging in, but you can't do it. Anyways, a polynomial is an expression, which means what? As opposed to an equation?
Simplified.
No. Parveen?
Oh, I have a question.
Oh.
What's your YouTube channel? Because I tried to find
It's right there.
All one word. Maxi Myers 9. An expression is, of course, no equal sign. There's no answer. Okay? You can only simplify or manipulate it. You cannot answer it. Okay? All right. So it is an expression consisting of rational variables and constants. Coefficients are also okay, as long as they're rational. All right? So very, very quickly, would that be allowed in a polynomial? Yes, it's a whole number, and it's rational. Would that be allowed in a polynomial? Yeah, because it's rational. Would that be allowed in a polynomial? No, because that's irrational. Everybody cool? Now I'm going to really mess with your heads. Would that be allowed in a polynomial? Yes, why? Because it's rational, because that's actually 4. Everybody cool? Yeah? Okay. Oh, I got another one that's going to mess with your heads. Would this be allowed in a polynomial?
Yes.
In a polynomial, would that be allowed? No. Why? Because that's the root of t, and you don't know what t is. Cool? Everybody with me? If I told you t was 4, would that be allowed?
Yeah.
Yes. Okay, good. Everybody's cool. Excellent. Now, we move along. Moving on up to monomials. Monomial, like a monocle, is
1.
1. A monomial is 1 term. That's the proper word. A term is just that. Any combination, and I'm going to write combo because I'm lazy, any combo of multiplied, please highlight, underline, Mrs. Bad Crumble star, I don't care, multiplied coefficients and variables. Okay? They must be multiplied. Now, does that therefore include division? Yes or no? Yes, it does. Why? Because what?
Because if you multiply it and divide it.
If you're multiplying by a fraction, you're dividing. Understand? So, is that a monomial? Oh, multiply. I kind of screwed up the definition with that first example. Or a constant. Sorry. Is that a monomial? Yes. Is 3x a monomial? Yes. Is 3xyz a monomial? You can't just say both and wait till I give you the right answer. I'm just going to stare at you with my poker face on. Poker face.
How do you wake up, Lady Dog?
Poker face.
There you go.
Now, I'm going to look at you with my poker face until you give me a yes or a no and don't waffle.
No.
Wrong. That's all multiplied, right?
Yeah.
So, is it a monomial? Yes. Everybody understand? No matter how many letters are together, 3 A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z squared. Is that a monomial? Yes. Okay? Even if I use the letters that Dr. Seuss made up in the book On Beyond Zebra, or zebra, depending on how you say that word, it is still a monomial, as long as it is multiplied. So, a binomial, like a bicycle, must have two terms. If it's multiplying and dividing that makes it a term, then what makes the next term? Adding or subtracting. So a binomial is a mono plus or minus a mono. Okay? Doesn't matter how big each monomial is. If they're separated by plus or minus, you have a second term. Cool? Everybody good? Excellent. I'm not even going to do examples because we just talked about what monomials are, so you should be okay, yeah?
Yeah.
Yeah, sure, you betcha. And a trinomial, like a tricycle, 3 terms. So what do you think that is? Mono, plus or minus mono, plus or minus mono. Okay?
Could it be mono plus binomial?
Well, yeah, mono plus binomial, because a binomial is mono-mono. Alright. Everybody good?
Doing math and
Everybody good? It's easy peasy, yeah? Okay. The next thing, the degree of polynomials. The degree of polynomials exists really only for one reason: organizational purposes. Okay? It's the only thing we care about. The degree is simply the highest sum, please highlight sum, of exponents of variables in any one in any one term. So here's what I mean. 3x plus 2. What would that guy's degree be? 1. Because the variable has an exponent of 1, there's no other ones there, so that guy's a 1. Got it? What would this guy be? 3xy plus 2x plus 1. 2. Because we only care about variables. Okay? Because that guy's a 1, that guy's a 1, that guy's a 1. So these two add up to 2. Everything good? And finally, what would this guy be? 3. 0. Because no variables. Everybody good? Now when I say this is used for organizational purposes, when we finally write our final answer after simplifying all of the polynomials that we can simplify, we write it in descending degree and or descending exponents of x. Now when I say x, I mean alphabetically, because we don't always use x. So if it's got x's and y's in it, what gets used first? X's. If it's got x squareds, x's, and y's in it, what gets used first? X squared. If it's got x squareds, x's, y squared, and y's, what order would you write that in? No. X squared, x, y squared, y. Everybody got it? What if it has x squareds, x y's, and y squareds? What order do you think you'd write that in? That one's a little confusing, so I'll write it out. It's got x squareds, it's got x y's, and it's got y squareds. What order would you write that in, do you think? Nope. Descending exponents of x. Keep all the x's together. So we're going to do the x's, and then there's another x, so that's 1, that's 2, and that's 3. Cool? Now guys, I don't really care about that. That's very persnickety. Okay? On your provincial, they won't even be that mean. What will happen on the provincial is you might do a bunch of work, get an answer, and then they'll put it in just the right order, and you might have to move your stuff around, but they would never have the right answer and then the right answer in a different order. Do you understand what I'm saying? They won't do that to you. That's too mean. Okay? Everybody good? At least I've never seen them do that. Okay? Alright. Now, we will begin our polynomial multiplication journey with this. 5. Mono, bi, or trinomial? Mono. Times x plus 1. Mono, bi, or tri? Binomial. Excellent. Now, please notice that in grade 10, for some strange reason, 6 years ago, they decided it wasn't good enough if you could do math with numbers. They decided that, no, sorry, that's not going to cut it. You also have to be able to do math with pictures. Now, when I was your guys' age, the pictures were used to help the kids who couldn't do it with numbers. And sometime between 1989, when I started Math 10, and about 7 years ago, they decided that no. Even if you understand the numbers, we're going to make you learn the pictures anyway. And strangely, the kids that get the numbers often don't get the pictures very well. So their grades actually went down. I don't make these rules. I just have to enforce them. My wife is a good example of this. My wife cannot use algebra tiles at all to save her life. But she can do university math. Algebra tiles are, of course, stupid because they will only work on things up to squared. And as you are well aware, every so often you are faced with an exponent higher than 2, aren't you? Yeah. But, again, I don't make the rules. Nobody elected me to be in charge of education in Victoria, so we are forced to learn these rules. Okay? So we're going to do that. First, I need to remind you of algebra tiles. There are 3 of them. It starts with the little guys. That guy is positive 1, that guy is negative 1. If you put them together, what do you have? 0. So they cancel each other out. We all remember this, yeah? Now, if you take these guys and you line up about 5 of them, the next tile is a bar that's just a tiny bit longer than 5. This is exactly 5. This is a tiny bit more. Since you don't know what it is exactly, it is an unknown value, yes? So that is x, because you don't know. It's also a, q, p, whatever the variable is. Then, of course, a negative 1 is shaded in negative x. And that, of course, will give you 0. Right? Then, if you take that bar and you multiply it by itself that way, you get that didn't work as well as I had hoped. Damn, that was going to be so cool. You get that, which is, of course, x squared, and you get that, which is, of course, negative x squared. We all remember this from the 9th grade, yes? Some of you may have had teachers that didn't even teach to you in the 9th grade, even though they were supposed to. If you didn't, you have now seen it, and that's all there is to it. You need to use it 3 times today, once on your test, once on your provincial, and then never, ever, 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 ever again. Okay? Until your kids are in high school math and they have made it so easy that all they're doing is playing Jenga. Yeah. Is my only guess. Okay? Alright. So, first thing we're going to do is we're going to deal with this algebra tiles. Well, this expression we know means this, yes? 5 times x plus 1. And you guys remember when Mrs. Bad Crumble was teaching you multiplying back in grade 3, one of the examples she used to teach you multiplication was this. If I cut this in half, and then I cut it into 3, I have 2 and 3. And 2 times 3 equaled 6. We all remember that from Mrs. Bad Crumble. If you don't remember that from Mrs. Bad Crumble, you of course remember it from our unit on area. Because 2 times 3 gives you the area of the rectangle, yeah? So, that tells you that in a multiplication question, the sides of the rectangle are the question. Am I writing it down?
Yes.
Did I say don't write this down?
No.
No. The sides are the question. Now, if you care, there's fancy names for that. One is the multiplier, and one is the multiplicand. I don't care. The sides of the question. Okay? And the middle is the answer. So in this problem that we are working on, which I have kept written in blue, The question is 5 times x plus 1, yes?
Yeah.
So that is what must go on the sides of our rectangle. So let's draw a rectangle. And on one side, we're going to draw the constant 5. That's positive. So we draw 5 little guys. Cool? Yeah? Everybody is good?
Yeah.
Awesome. And the other side of the rectangle is the other side of the question, which is x plus 1. X, and then a positive 1. Everybody still cool? Okay, now, the middle is the answer. So this little guy is multiplying by this bar. So we start with the little guy, don't draw this yet, and then that little guy stretches to the length of the bar. Okay? And how many times is that going to happen? 5. And then 1, there's no stretch, so it stays the same, giving us the answer in the middle of the rectangle. What is it? 5x plus 5. Okay? You have to know how to do it 3 times. There's once. Okay? Now, for you guys who actually understand math and numbers, we're going to get completely away from playing with blocks and counting to doing actual math. Okay? Now, algebraically has another name. Okay? The other name is symbolically. And it depends on who types the provincial exam this year for which word they are going to use. Because let's be honest, don't write this down, is that 2? No, that is not 2. That is the symbol we use to represent 2. This is 2. This is 2. This is 2. This is 2. All of those things are represented by that single symbol. Do you understand? Now, if we were in Roman times, what would the symbol be? I. Okay? Everybody picking up what I'm putting down? Yes. So algebraically also means symbolically. And what does that mean? That means numbers. And this is what you guys already know. Okay? Now, you guys last year were of course taught this, but I'm going to go back a step. We are doing 5 times x plus 1. Correct? Okay. So that means 5 is multiplying how many things?
2 things.
2 things. So this is really 5 times x plus 5 times 1, which is, of course, 5x plus 5. Yeah? That is what you're actually doing. Now, in grade 9, your teacher showed you the distributive property, which is this, and in a shortcut. You didn't have to write it all out. And the distributive property is simply this. The coefficient, I forgot the second I in coefficient, you please spell it right. The coefficient before any polynomial multiplies each term polynomial. Okay? Now, remember, there's two rules here. We have to care about coefficients variables and exponents. Okay? And we're going to go over that in a second. But first, we're going to write out what the distributive property actually means in as simple a way as I can. Parveen.
Isn't that just like the arrow?
It's the distributive property, Parveen, because that's what it is. I'll get to what you're talking about in a moment. A, comma, B plus C. Is A a coefficient? Comma. I said comma. A bracket. Does that come out, by the way, when I smack my head? Can you hear it in the recordings? I wonder. We'll check today. I don't know what time it is. Everybody cool with that? Right? Coefficient, polynomial, right? Now what Parveen is speaking to is what all of your grade 9 teachers probably did. They drew one of these. And they probably called it flying arrows. I've already made fun of flying arrows when we did exponents. Because of course, if you go to university or anywhere else where math is actually done and say, I'm going to use flying arrows, they're going to say, why don't you go back to Sesame Street and do math there where you and Cookie Monster can count the cookies? Because what this actually is of course, the distributive property. And that's what it's going to be written out on your provincial. So if you're going to remember it as arrows, remember it as arrows. But remember it's got a real name. Okay, Jehoshaphat?
What?
Well, your name's not Jehoshaphat. So it was a joke. Never mind. So this, of course, is AB plus AC. It must multiply by each one. Okay? So, the first one we're going to do is the picture. Right? So, if we're going to do a picture, then where does this term, which I will draw in red, and this term, which I will draw in blue, live in our picture? Are they part of the question or the answer? Yes, they are the length and the width. So, draw a rectangle. The width is x. Cool in the gang? The length is 2 x's, and then minus 4. Guda? What lives in the middle? The answer. So this x is stretching the length of this x, isn't it? So I get this. Yeah? And then it happens again. Yeah? And then it doesn't stretch, but what wins? The colored. The shading. And of course that gives us our answer, which is what?
2x squared plus
2x squared minus 4x. That's the picture. Now, of course, us being in pre-IB are going to eschew those pictures, and we are going to do this algebraically. To do this algebraically now, while you're practicing, please, 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 do not be lazy. X, 2x minus 4. You don't necessarily have to draw the arrows, but it's very, very helpful, especially when the polynomials get bigger. X times 2x. Well, what's the coefficient with x?
1.
1. So 1 times 2 is 2. X times x? X squared. Because we add the exponents from our exponent laws. Minus x times 4, 4x. Everybody can distribute, yes? Okay. Please do that one only algebraic because of time purposes. I don't need a picture. We're going to cheat and go algebraic because this is our honors class. I'm going to write it out completely. Everybody cool?
Yeah.
Yeah? Okay. Turn the page over. Now, last year, you may have had a teacher that showed you how to do this. This is, of course, binomial times binomial. Your teacher may have shown you this, or he or she may not have. If he or she did, awesome, it's more review. If he or she didn't, please pay attention now. We are going to do again one picture. Is this question or answer? Question. So where does it go? On the sides. So we'll do this one red. How do I draw x plus 3? X, and then 3 positives. Yeah? Now how do I draw x plus 2? Which I will draw in blue. X plus 2. Yeah? Okay, now fill in the middle. Easy peasy lemon squeezy. And what's our answer? Finish drawing yours, no rush. You don't need to. X squared plus 5 x's plus 6. Goody good? Everybody can count, yeah? Okay. Algebraically. Now I'm going to show you this algebraically first in a very inelegant and ugly way because that's what it really means. Okay? Then I'm going to show you a pretty way to do it. Then I'm going to show you an even prettier way to do it. Okay? First thing we're going to do is take care of this algebraically in the ugly way. X plus 3 times x plus 2. Pretend there is no 3 here. Okay? So that means we have x times x plus 2 times x. Does everyone agree? Because that x needs to go to both of them. Is everyone cool? Now, pretend that there's no x. So the 3 has to go to both of them. So I have positive 3 times x, so plus 3x, plus 3 times 2. Is everybody okay with that? Yeah. Now we simplify. X times x is x squared plus 2x plus 3x, 5x, plus 3 times 2, 6. Yeah? Okay, same answer, yeah? We did it right. So now we'll move on to the first slightly more elegant way. This fun acronym, FOIL. Some of you will have seen it. It stands for first, outside, inside, last. And we're going to draw it out nice and big over here. X plus 3, X plus 2. I'm going to do first in red. What would you say is the first thing you see?
X.
X. So X is going to multiply by the first thing he can, which is X squared. X again. So that gets us X squared. Cool? Then I'm going to do the outside, which I'm going to do in black. Outside is the guys on the outsides, X and 2. So that is positive 2x. Cool? In blue, I'm going to do insides. Insides are 3 and x. Now please look at what I'm going to do. I'm going to do something slightly weird here. I've moved on to a new term, so I'm going to move on from line A to line B. And I'm going to put that 3x with the like term that he's buddies with. Okay? And then I'm going to do last in green, which is, of course, 3 times 2, which is 6. And then the last thing I'm going to do is collect my like terms. X squared plus 0 is what?
X squared.
X squared. 2 plus 3 is, of course, 5x. And 0 plus 6 is, of course, 6. Everybody cool?
Yeah.
You're going to practice that about 1,000,000 times. But remember, I told you I'm going to tell you a prettier way to do it. But I'm not going to write it down. Because if I write it down, you guys will all start using that and not actually do your work ever. Okay? The prettiest way to do it is something that you will have to get to by yourself. But I will call your attention to 2 things. I will call your attention to positive 3, positive 2. And then I will call your attention to 5 and 6. And I will ask you if you can decipher the shortcut. I will not write it down. But I will tell you that in about 1 second I can tell you the answer to this is x squared plus 3x minus 4. Without doing any foiling. Okay? And that's all I'm going to say about that shortcut for now. You guys show me that as an algebraic solution with work. Go. Can I give you an outline for this unit? It's on the front page of your sheet, right?
Yeah.
Okay. Foil, first outside, inside, last. If you need to draw the arrows, draw them. Is everybody Buddha? Okay? Everybody can do it?
Yeah.
All right. We're done? please, on your outline notice, I have asked you to do some math. Here is the way to approach this unit. Do this each question until you are doing it right.
Okay.
Then, move on to the next question, for all I care. After you have done page 186, the next page, the B4 assignment, that is what I will actually be looking for tomorrow. The textbook work is your practice because it's got the answers in the back. Okay? I am well aware of that high school thing where you write out the question from the textbook, scribble a bunch of numbers, then go to the back, find the right answer, then show me the work the next day and say, see, it's done. Because that's how I got through grade 8, 9, and 10. Okay? But I am smarter than Mr. Posnikoff, Mr. Voff, and Mr. Stewart, who are my grade 8, 9, and 10 math teachers, because I give you guys extra stuff with no answers, with which you must work to prove to me you know what you are doing. Clear? So you start with page 186 until you are comfortable knowing what you're doing, and then you do the next page in your notes. Got it? Go!
Okay.
No, get out your textbook.
Done.